Alright, let's take a look at another graph problem. This is from 2012. They give you a function, and that is f of x, I suppose, drawn over here. And they tell us that g is equal to the integral from 1 to x of f of t dt. So realize that you have to interpret this as the area under the curve is what g is equal to from 1 to x. So first thing they ask us to find is the function value g at 2. So g at 2 is going to be from 1, replacing 2 with the x. So you can see that this is just going to be the area under the curve from 1 to 2. And from 1 to 2 it looks like it's a negative value. And the second part over here tells us to go from 1 to negative 2. So the first thing you notice right away is that the order of this integration limits are out of order. So if we reverse these, it's perfectly fine as long as you remember to take the negative value of that. So it's kind of what we're going to do. So let's just take a look at the area. From 1 to 2, we're going from this spot to 2, so there's not a definite point, but we notice that the slope of this blue segment here is down 1 and over 2, so it has a slope of a negative 1/2. So this height is going to be a negative 1/2. So the area formula for the triangle would be 1/2. The base is equal to what? 1, and the height is a negative 1/2. So looks like multiplying that out, we get a negative 1/4. Alright, and now for the second one, we have to switch the limits, so we're going from 1 back to negative 2. So we're going from here to our starting point right here. So we have a semicircle, and remember that whatever we find, we're just going to reverse the limits. So for the circle, or for the semicircle, the area is 1/2 pi r squared, and the radius of this is 1. So we have 1/2 of pi. It's negative. Radius squared is 1, so negative 1/2 pi is this area here. And then going from this negative 1 to this negative 2, it's a triangle. It's positive area. So it's 1/2 base times height. Base is 1, and the height is, looks like 3. So that would equal positive 3/2. So we're going to add these two up, and looks like we're going to get common denominator of 2, right? Adding these two up. So you have positive 3 minus 1 pi. And remember, we're taking the opposite answer here. So we have negative quantity here. Distributing the negative, we would get what? Positive pi minus 3 over 2. Alright? Not too bad. Second part tells us to find the derivative value, g prime, of 3. And recall that if we take the derivative of g, we also have to take the derivative of the integral over here, right? Well, first thing we remember is the second fundamental theorem of calculus. And since we're taking the derivative of the integral, and x is in our upper limit, all we have to do is remember that they cancel out. So g prime derivative of g is just equal to the function over here. So all we have to do is go to this graph and go over to 3 and realize that g prime of 3 is equal to f prime at 3, and f prime at 3 is a negative 1. Alright? Well, the second part is asking us to find the second derivative. The second derivative of g is equal to the first derivative of f. So at 3, since we have a line segment here, the derivative of this is just the slope of this, and we found out earlier that the slope was down 1 over 2. So the second derivative of g at 3 is equal to a negative 1/2. Okay. Okay, taking a look at part C, it says find where G has horizontal tangents, and then talk about whether it's a relative minimum or relative maximum. So, if you'll recall, we are looking for where G prime is equal to 0, and since G prime is equal to this function, where is G prime equal to 0? Well, it crosses here at a negative 1, and it also crosses, becomes 0 at positive 1, right here. So, those are a horizontal tangent, so that's probably a point right there. And then we need to talk about whether it's a relative minimum or relative max. Remember, you have a relative minimum or relative maximum when the derivative changes from positive to negative or from negative to positive. So to the left here, it's positive, and then the graph becomes negative here. So a positive to negative at negative 1 indicates what? We're increasing over here, and we're decreasing on the right side. So that looks like a relative max. So relative max at x equals negative 1, and the justification would be because you have it changes signs from positive to negative at negative 1. Relative max because of the sign change from positive to negative. Okay? Well, let's go take a look at the other side. At x equals 1, it's negative over here, and then it reaches 0, but then it turns to negative again. So, because it never changes signs, it's not a relative minimum or a relative max. So, that's the only thing we have to say about that one. Well, part D says points of inflection. So points of inflection for G, we're looking for where the second derivative equals 0, or where the second derivative is undefined. And so undefined, we talked about the derivative would be where it has a cusp or some sort of a sharp corner. Now it looks like it has a sharp corner here. So possible point of inflection might be x equals a negative 2, and looks like another sharp corner at x equals 1, and then no more sharp corners here, but you notice that there's a horizontal tangent for g prime. Remember, f of x is equal to g prime. So the second derivative would be this horizontal tangent right here. So we also have to look at where x equals 0. So here's our three possible points of inflection. Alright, so now we need to go look at the definition of point of inflection. A point of inflection is where the concavity switches from concave up to concave down, or it could be concave down switching to concave up. So basically we're looking for a sign change. Let's take a look at our first cusp, our first sharp corner, the slope of this G prime is positive tangent line, and then on the other side we have a negative tangent line, so it goes from concave up to concave down. So x equals -2 is a point of inflection, and then where it's 0 right here, to the left of it we have negative, and then it switches slopes to positive. So x equals 0 is also a point of inflection, and at x equals 1 we're positive, and then we switch to negative. So all three of these are points of inflection. Alright, hope you were able to follow along with this problem, get comfortable with them, and realize that once you understand the concept, these are not that difficult problems.